Home automation is in vogue and can set you back hundreds or even thousands of dollars. But with a little technical skill, an Arduino and 433 MHz radio, you can get started with basic home automation for as little as $50. Would you like to see how? A basic home automation system has electrical outlets such as these from BN Link that are operated by a remote control. The remote emits a radio signal at 433 MHz. The signal is received by all of these outlets in the set and decoded. So the target outlet is switched on or off. By intercepting the transmissions between the remote and the electrical outlets, the transmitter and the receiver, we can discover these codes and then use them in our own program to control home appliances. This is a short video about hacking radio frequency transmissions using the Arduino. What we need is wireless remote controlled sockets, electrical sockets with the remote control, an Arduino. I've used an Arduino Uno, and a radio frequency receiver. And on the software side, we will use a library called RC Switch for the Arduino framework. Making the connections is extremely simple. You have the Arduino on one side and the receiver, radio receiver on the other. GPIO number 2 is hooked to the data pin of the receiver. This particular chip has a chip select which needs to be high to enable the chip. I've hooked it up to GPIO number 13 of the Arduino. The receiver also requires power, VCC and ground. I've drawn power from the 5-volt pin on the Arduino and connected to 2 grounds. Here is the physical realization of this circuit. The orange wire is 5-volt of the Arduino, the yellow wire is ground. These are connected to the VCC and ground of the receiver. GPIO number 2 on the Arduino is connected to the data pin of the receiver. GPIO number 13 is connected to the chip select. GPIO 13 needs to be high to enable the receiver. Observe that when I press a button on the remote, the LED labeled RX on the Arduino blinks, indicating that it has picked up the transmission. And I can also see the transmission here on the serial monitor. By pressing each button, I'll now discover what is the message that is being transmitted, and then I can save it and use it in my program to design my own control system. What are these codes? You see, radio communication works by putting a signal on a carrier wave that can travel long distances. A message is encoded in features of the carrier wave, such as amplitude or frequency, giving us AM and FM radio. In 433 MHz communications, the carrier is a square wave and a binary message is encoded in a pulse train. Think of it like Morse code with dits and das. A transmission is 32 bits in length, so we see a 32-bit number. We can convert it to an integer. We also get the raw waveform in this set of numbers. So now that we have intercepted the transmission and decoded it, let us see how we can use it in our own control software in the next video.